So why is data governance critical to success? Well, plain garbage in, garbage out. If you have bad data coming in, you're never going to get good results from the data coming out. And a perfect example is this, right? If you try to add these two numbers directly without any translation, you're going to have an imperfect image of your salaries across the enterprise. The numbers themselves are going to be wrong because of the semantics. And somebody that's consuming that is going to figure it out. And it's not just one-to-one. This is what your data processing looks like within an enterprise, right? You have these very large, complex, directed acyclical graphs of processing. Data gets transformed, 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 right? And if you have semantic incongruities in those aggregations of aggregations of aggregations, you're going to think that you're building the tower on the right, on the left, and you're going to end up with a tower on the right. And it really comes down to customer trust. If you're building large-scale big data processing, or you're running artificial or machine learning on that data, and somebody finds a semantic incongruity in one place, the trust is crushed for them. They're going to begin wondering and questioning all the numbers, all the aggregations that you're producing. So if you don't have solid data governance for this, you're going to go to one side, not the other. So it's all about knowing the data governance, right? You need to know the semantics. You need to know the lineage, where the data came from. You need to know, as part of that lineage, its transformations. Oh, at this stage, we normalized the French data and the American data to mean the same thing semantically. There was a step upstream that did that. You need to know that. You need to govern that. It can't just be hidden. You need to understand the disruptions and the corruptions. And just wouldn't be complete without touching on this. Regulation, right? In the United States, and in Europe, they have very stringent laws now about personal identifying information, people's privacy. In the United States has healthcare law called HIPAA, which has very stringent rules about who can see what data. And then Europe has just passed GDPR, another very stringent law, which pretty much says a customer can at any time say, delete all my data. Right? And if you don't have data governance, you're never going to be able to meet. I would say that data governance is a prerequisite in order to implement GDPR. So to summarize this part of the talk, data governance is the orchestration of people, processes, technology, and policies to ensure data availability, usability, integrity, consistency, auditability, and security. And the business objectives are as what we stated: to understand the implications of data outages, to recover from them quickly, and to rapidly fix them and mitigate the impacts. It's not going to eliminate it. You are understanding and mitigating. Think of it as an insurance policy. An insurance policy doesn't mean you're going to wreck your car. It doesn't protect you from wrecking your car or getting your car hit, but it mitigates the problems when the car gets hit. So, how are we doing on time? I feel I'm going very quickly. Okay. So what are the tools that are available? Because you're talking about all the data of an enterprise. And we already talked about the physical limitations that humans have. So you're going to need tools for this. Now there's a lot of commercial tools out there. Collabora, Informatica, Datum, SAP. A lot of enterprises already have these tools in-house, probably not using them, right? They're sitting on a shelf. They probably bought the license for them, but they're not employing them. But then there are open source tools as well. And the four that I want to focus on here are Apache NiFi, Schema Registry for Kafka, Apache Ranger, and Apache Atlas. All open source, all integrated for big data. So the first one is NiFi. Now, just a show of hands, how many people have heard of NiFi? Okay, not many. So even fewer, I assume, have used it. So NiFi, it used to be, the name was Niagara Files, as opposed to Niagara Falls, which is a big waterfall in the United States. It was designed by the United States National Security Agency, NSA, which is responsible for collecting signal not only in the United States but all over the world. So they had a big data problem. And they had a problem of being able to collect data and move it to their central processing. So they invented NiFi for it. It is in essence a drag and drop pipeline creator for ETL, for moving data to data lake. And it was released as an open source project and is now part of Apache and supported by Hortonworks. This is an example of the kind of flow that you would create with NiFi. I mean, it connects to sources, handles transformations, and uploads into your data lake. But what's nice about it is what differentiates it from other ETL tools that we've seen. First off, it's open source, but second, it has a very strong data provenance, which means every single time it moves or transforms data, it records that. So you have all the metadata about and all the lineage of your data from start to end. And it will even graphically represent that for you. So you can go into a particular record and say, how did this get created? And you can trace it all the way back through all the steps and all the transformations that occurred from the end result to the sources. The other part of it, so that gives you a big picture into how your data got into your data lake. And the second thing is schema registry, which complements NiFi. Because a lot of NiFi processes and a lot of just straight ingesting relies on Kafka. And how many people here have worked with Kafka so far? Okay, a lot more. All right. So with Kafka, it is an append-only log, which is used as a message bus. And what you're doing usually is writing a Avro message onto that topic, but you can be writing anything. What schema registry does is it automatically registers the schemas, hence the name, of the messages that are being written to the Kafka topics. And it also allows you to enrich this information with documentation, so that you can go and say, okay, what are my topics in my Kafka? And then what is the schema of the messages on that topic? And then what does that schema mean? What is the semantic meaning of it? When you're dealing with one or two topics, that's kind of But when you're talking about thousands and thousands of topics running an enterprise, that becomes very critical. Another key part about it is that it versions the schemas for you. So it allows forward and backward compatibility and evolution of those topics. So a lot of things I talked about there. Centralized registry, version management, and schema validation. So that people, things that are writing to the topic can have their messages checked before it's written, and things that are reading from the topic can make sure that the messages are semantically intact, valid. Another big tool for use in your big data governance is Ranger. Now, security, as we've touched on, is one of the aspects of big data governance. And Ranger is the central place of managing security policies within a Hadoop cluster. And What's nice about it is it's not really Hadoop-centric. So I foresee Ranger evolving to other distributed platforms such as Kubernetes, Mesosphere, and whatever's coming next. And the way it works is by plugins. For each different particular type of tool that you're dealing with, there is a Ranger plugin that goes with it that enforces access. So you have one for HBase, for HDFS, for NiFi, and Yarn, etc. So when you go into Apache Ranger, you're able to specify security policies for the access of that data. And we'll touch on that again real quick. But the biggest tool in your arsenal for data governance is Apache Atlas. And just a show of hands, how many people have had a chance to work with Atlas yet? Very few, probably. I don't see anyone besides Rick or Lyman people. So, and it's not surprising. Atlas, first off, is very new. The documentation isn't what it should be, and the evangelism hasn't been what it should be either. And that's one of the reasons why I wanted to give this talk, is because I believe that this open source project is very critical to the future success of Hadoop and big data and eventually data science. So one of the things it first does is it automatically allows you to search all your metadata of all your tables within your Hadoop or within your Kafka or within your HBase, etc. And the way it does that, you can see here that, or maybe you can't, the person has searched for tables with the name like SalesFact, and it's found 3 of the tables within the data lake, right? Or within the cluster. So the way it does that is, like Storm, it has plugins to all these different frameworks. So it is automatically gathering all the metadata from HBase, from Hive, from Kafka, Storm, etc. And you'll see also that it has not only just data at rest plugins, but data in motion plugins, which is absolutely critical for that concept of data lineage. It's not enough to know that this is a Hive table and what the schema is. You need to know what wrote the Hive table and what sources did it pull data from when it wrote that. And lo and behold, that Atlas gives you that out of the box. So if you drill down into a table to get more information, you'll see something like this. You'll see a graphic representation of the lineage of that table, what processes wrote to it from what tables, upstream tables, and then it gives you a lot more metadata about the table, and it'll give you metadata about the columns, etc. And sometimes the lineages can be quite complicated. What's also nice is this plugs into NiFi, so all that lineage information in NiFi can be, because NiFi only gets you to the edge of your data lake, and then you have all this processing from Spark, etc., inside your data lake. This allows you to have a common view across both. And another thing it does for you is it allows you to create tags. So not everything is going to automatically be generated. You're going to have the humans get involved. You can assign taxonomies to your data here, and you can assign tags to your data. So for instance, you can go in and say, this is a table that has customer information. This is a table that has product information. This is a column that has personal identifying information, right? PII. So you can find that information all across your enterprise. But what's really awesome is the fact that it will then integrate with Ranger. So the tags that you apply to data can then be turned around and used for rules of access. And one of the examples that they give is expiration date. You can create a tag on your data called expiration date, and then for particular tables or even particular sets of fields, you can assign the expiration date of that data and then block access based on expiration date to certain tables. So that's a full circle of how data governance with these tools would work, which would be very problematic otherwise. So data governance tools, that we recommend here, NiFi, Schema Registry, Apache Ranger, and Apache Atlas. They work together to make, to start moving along to that data governance and enabling it.